All right, let's get started. Bit in a hurry. Put my coffee. Um, Let me adjust my microphone. So what's up? What's up? There we are. Enough waiting. Let's get started. I think I have to adjust the view. Let's go bigger. So what did I leave at yesterday? Let me check everything is right. Mic test, mic test. Okay, all good. Cool. Stream is fine. Great. Cool. So where did I leave it at yesterday? I was creating the sub allocations. So we got the staging buffer, and also got the delete queue, which is in place. It's not implemented yet. But I've also noticed there is a bit of a problem here because the vertex buffer, the offset is always 0, which isn't ideal as we want to flip we flip on different frames. So let me try to get a little drawing board. No, I always get it wrong. So Control 2. I'm gonna go red. Let me visualize this. So we got the vertex buffer, which is a huge array, and then green. Then here we go by drawing. That will be the first drawing command that is going to use this bit of the data. And then we're going to create the next frame, which will be executed like there will be multiple frames, multiple in-flight frames. So this will likely be executed afterwards, but it needs to be generated beforehand. So if I'm doing the write here, so this is the write operation, and the next write operation happens here, which is going to overwrite the same area. That isn't good, right? So that's something we need to fix, and this write operation needs to point. So this guy here is going to write there, and the next iteration this guy needs to write somewhere else. So we need to sub-allocate also the destination buffer in a way that this can do that. And then after some time, let's say we have done also this frame, third frame, and then we're done with the first frame, and then we can boom reuse the first frame again because it's free, and that will be something that frees it up. Cool. Oi, 42, welcome back. I was working on a mod for Minecraft today, and then my power got up, and oh no, that sucks. Yeah, that's the worst. So you are on a desktop. Yeah, maybe you should see if you can afford a cheap like UPS. That's a lifesaver. Even though I haven't bought it yet. But I'm planning to buy it because that's not great. Also, maybe you can, yeah, I suggest you to say, I don't know if you're using a version control system. So that's a good idea. And then you save often. So that also allows you to go back in time pretty quickly. And still, I think I haven't saved my state in a while, so I should probably commit at some point. Okay, so I guess I need to suballocate from the vertex buffer too. So I got the staging buffer allocated, and then I need to suballocate from this guy here. So done the copy, and the copy is fine. I just need just need to suballocate from the vertex buffer. How much data do I need? Not again. Oh, you didn't save it at all. Ah, that's the catch. Yeah, never do that. But, like VCS is it's free, so just push your code into some cloud stuff. Unless it's a trade secret, which probably isn't. So just use GitHub. It's pretty safe. And I must say that it's also nice to have it on GitHub because and have everything nice and tidy. At least try to put the effort because then it's gonna look nice in a few years. And you go back and see, oh, this is what I've done, and these are all my projects, and it's also easier to share with people. So let's go with a sub allocation. Device. That's the copy. How much do I need? Okay, I guess I have to compute the size by myself. That's gonna be the VBO size times yes. And okay, also the alignment. Okay, that's fine, I guess. What's wrong? Oh yeah, I didn't save. So we need a copy. No, it doesn't have to copy. I just need to read from this. So it can be const. And we're gonna auto. And that is the destination subbuffer. Okay. We got the destination subbuffer. Now what we need to do is to copy. Oh yeah, let's not forget. Maybe I can put these together at the bottom. Buffer suballocation delete. Maybe I can make a function to do that. Might be. Yeah, especially if it's a binary file. That's harder to to get back if you have binary files. But if there are source files, I mean, how bad is it? Did he corrupt the whole system? I hope not. Because sometimes when you when the partition table gets corrupted, that's the worst. Or the file system index, that's great. By the way, I need to update this because it doesn't come from that buffer, it's from the staging. So I also have to update it here on the bottom. So this is a staging, and this is also the staging. Yeah. Okay. What I'm left with is staging vertex, but this is SB destination, or how did I call it? Oh, destination SB. So that's destination SB, and here we use destination SB dot offset, and that's it. Okay, got the destination offset. Now we do the same thing here. I copied I'm gonna copy all of it. Delete this. It's just gonna allocate from this was, oh damn, so this is from the UBO. Okay, so that's the frame buffer. It's a per object. The size, I shouldn't have copied this way. So the size is UBO, and the type is per object. Per object. Okay, the copy is the same. And we defer the staging and the frame buffer destination. Okay, cool. Now for the last guy, wait, copy a command pointer. No, wait, it's missing. Oh no, this is the copy from, okay, no, it's not missing it. So this is it. So suballocation, and the type here, it's this guy, and it gets it from drawArgs. Okay. And the buffer is the draw args, yes. And we interpret from the args buffer, and the staging buffer is fine. Am I missing anything else? Oh yeah, not from the vertex buffer. So this needs to be allocated from the args buffer. Okay, all matching. This is not all matching. This is the frame buffer, and the copy is on the frame buffer. And here's the vertex buffer, vertex buffer. Okay, so this is all good now. We've got everything lined up. Always wanted to make a game. Guess this is VCS or something. Looks complicated at first. VCS? No, this. What do you mean VCS? This is C++, and I'm doing yeah, somehow Minecraft inspired game for VR, and I think, yeah. And yeah, I need to fix this stuff. Visual Code. No, this is not Visual Code. This is C Lion. I didn't use Visual Code because it didn't work well for me, at least at the beginning. I probably didn't set it up correctly. It didn't get the. I'm using C++ 20 modules. Have you ever made a Roblox map? No, not really. I know there's an editor. I want to check it out at some point. But yeah, I don't play much my Roblox anyway. Descriptor. Yeah, so this is Sea Lion and it works fine. It's the free version of Sea Lion. I probably can. I could give it a try to Visual Studio Code again, and I just have to set up the language server correctly. So I'm using C++ 20 modules with Visual Studio doesn't handle very well, and probably also Visual Studio Code by default. Yeah, I know that Roblox uses Lua under the hood. I might give it a try at Lua. It sounds fun to have. There are other scripting languages, but I would probably have to play around with the reflection before doing that. Otherwise, C++ does not communicate well. I don't want to do all the manual bindings, so it's probably a good idea to have some reflection at some point, but not at this level. Right now, I'm just working on the render, so the low-level rendering system. Let's see. So we got all the buffers, and what is missing is the descriptors part. And there is an there's a garbage collection. Okay, so I renamed these variables. So the staging buffer, the delete buffer. So I renamed it, and now I need to claim this function. So this is the function that does the garbage collection. And that's going to be buffer. Can I like keys, use view keys? I don't want the keys, I need the values. I can destructor this. Yeah, I think I can so the buffer, so there is a fence. It's not a fence anymore, it's the timeline, and it's a uint 64. And then I don't want to wait for them. I want to check if it's already passed. Let me get a help. So how do I check if a timeline semaphore value is passed? I don't know. Should be able to understand. I'll get semaphore counter value. Okay. Okay, we need the value. Something like that. UN64 timeline value. And then we check if const. Oh, come on. We don't have it. We need to get the value of it. Okay, we need a variable that is updated. What is the current value? Yeah, we need the current value from XR and VK. So this code needs to run inside one of these functions. And let's say that I want it close to present. Oh, it's timeline value. Well, this isn't const, is it? I don't know, let's see. Oh, and the value is definitely not this card. Oh. It's gonna be UN64. UN64. Let's say, yeah, I mean, can this have a, well, let's make it optional in case it fails. So that's the value. And then if the result of the timeline semaphore, which I think is timeline semaphore, you get value, and the device, this is like this, okay? Yeah, that's the device. Then we check for if it's not success. The indentation is broken today. I don't know what is it doing. Then we return null. We return a stud null option. Otherwise, well, maybe we can even log something. An error. Can you give me some suggestions? No, okay. Timelines for value fails. Okay, thanks. Otherwise, we return the value. What's wrong with you? Can you just give me? Okay, can we make const? Okay. Yeah, it is const. It's not changing anything. That's nice, even though it has a side effect. of calling a function, which is probably not. Any tips? Someone who wants to make his first game with zero knowledge, maybe on Godot engine. Yeah, Godot engine is probably a good starting point. It depends on what your focus is and where are you heading into. So if you just want to make a game, then Godot is a good place. Unity is also Unreal. Maybe it's a bit of a steeper learning curve, especially because you need to do some C++. Godot scripting is simple enough for you to understand. But I would also, if you want to head into a game development career, I would also start learning some C, even Python, I guess, something that makes you understand how logic programming works. I don't know if you have any experience in programming, but that's a good advice to start with programming. At least to do something. Then you can get into game development and also learn some art. So that's also a good thing to know. If you can learn some art tools, just because otherwise programmer's art is not great. Good luck with your C++. Thanks, Kakra. It's difficult to make VR game. Is it difficult? Not really. I mean, it's just another platform. Actually, I would say it's easier if you're not targeting multiple devices. Like, the good thing is that the devices park is not too large right now, and you probably want to target Android with pretty capable devices. So it's a very well-defined set of devices. It also depends on what you are really talking about. Like if you mean about the gameplay, well, you need to have device and try it by yourself. But it's not more difficult than doing a normal game. It's just a different way of handling objects. So it has different requirements for the gameplay. It's not interchangeable with desktop games. So the experience is completely different. I would say it's easier to compete right now in the VR in the VR horizon because there are fewer games and you can focus on the experience rather than the graphics. People in VR are more willing to accept a poor graphics as long as the experience is good enough, and multiplayer is almost mandatory because VR is more a social platform. It's much more social than the desktop, where you can just enjoy a good game by yourself. Yeah, you can do that in VR as well, but since you are immersed, it's like it's much more involved, and at that point you just yeah, you just want to hang out with some people. Just like when you're walking around, and it's even better if you have someone to do it with. Unless you're doing just going out for running, then you don't want to meet anyone. All right, let's see. There are no errors. Is it gonna compile? So let's do the first test. Oh wait, I forgot that I just had this function that I haven't implemented. Oh yeah, I don't have red lines because I'm looking at the wrong file. Also, I need to copy this over this other class, which handles the XR render. And back to the application. Here, I need these values that I can grab from these two functions, which is the tick for the windowed and for the XR mode. So to merge those two, I will have a uint64, which is gonna contain the current semaphore value. It's gonna be 0. Semaphore value. Yeah, that is clear enough. And then first things actually that needs to happen before the garbage collector is called. Okay. That happens here. I don't want to. Should I? Okay, let's do it like this. Should be timeline value. How did I call it? Oops. How did I even call it? Oh, semaphore value. Timeline. Let's call it timeline value. That is XR. Is it XR? M. XR. Timeline value. What's wrong? Cannot assign. Oh, it's an optional. Value or 0. Okay. Cool. We have the timeline value. So let's remove everything from here. And then for each of these, say that if timeline is greater, what is the current value, greater or equal timeline value, then so want to delete objects. No, we can't delete. And let's call this remains. So we need to save the remaining to be deleted objects. At the same time, we don't want to touch this because it's going in a for loop. And so I have to create something that is similar to this guy without this ugly type. Buffer delete queue. Yeah, I'm gonna retype this to buffer, or maybe not. Yeah, whatever. I'm gonna just retype. this ugly name, and then I would say remaining, is it reminder? Well, how is it? Not deleted. Not deleted. Okay, that makes deleted, not deleted. Okay. So if this is deleted, then delete buffers. No, we don't want to clear. We just want delete buffers to be not deleted. Okay. And let's move it. Now, how do we delete a buffer? We need the destructor. So auto ref. So this is a reference. Ugh. That sounds ugly. And we want to destructor it into the buffer and the suballocation. So how do I call it? Buffer pair source. Let's call it source. No, that's yeah, buffer pair buffer and sub buffer, and that is the structure from the buffer pair. Then we want to do a buffer update. Wait, where's the dialog? What's going on? Oh, it's okay, not const then. Not const. But that is const. Okay. I see. So this can't be const. But that's fine. At least we know that now the intent is to modify it. I think now I can do a deallocate sub free. Okay, sub free SB. So we do the free. And that's it. Nothing else really happens. Like the buffer is not. It's just a deallocation. The buffer is not touched per se. And that is done. So everything has been deallocated. Uniform set index. Yeah, now I have to deal with the index. The descriptor sets. So far, the only one that I touched. Oh wait, I also have to update this guy. Oh no, this is fine. This is fine because this guy is using the whole. It's using the whole. It's using the whole buffer, but it's using the whole buffer. But they gonna run in conflict. I guess I would just put it as to do conflicting in flight. Resolve conflicting in flight frames. Conflicting. So this also needs to suballocate, but I also have to make the frame buffer. I think I've used frame buffer in the wrong place. Oh yeah. But this is not the frame buffer, this is the object buffer. Okay, that would have been a mess. Cool, we got that just in time. Bind vertex buffer. So I've created multiple descriptors for this guy. Now, okay, now I'll start with the per frame and shader. How do I call it? Solid flat. I need to. So first reset the descriptor for this frame. Which frame are we? And so I'm not carrying around this value, but I should. I think this is important value. So in the frame context, frame index, how do I call it? Let's render pass frame index or swap chain index. Yeah, I would call it swap chain index, is much more descriptive. And that is a unit 32. Doesn't even have to do 32. Unit 8. Well, I'm going to skip it. 32. But that is swap chain index. That should be descriptive enough. And this is happening before the time value. I'm just gonna find the usages. So which is right here. Present index is the current present index. Yes. So this will have value for present index. Dot swap chain index is present index. And I'm pretty sure the same applies on the XR. So we do have present index. Cool. Present index. Should I use present index? Swap chain index. Yeah, I'm gonna rename it to present index. Okay. So that's presentation index. And here I can use the presentation index. Frame.presentation index. Hey. Okay. Is that it? Expression result is not used. It's a Boolean. Is it even useful? Yeah, I'm just gonna ignore that. So this will do the reset. Then we need to set update descriptors. Update descriptors. No, update descriptors happens at the end. And let me quickly check if vk when vk descriptors is allowed to be run. So I think it cannot run inside the render pass, but it's just a suspicion. And run inside pass. Yeah, I would like to avoid opening the full specification. It's gonna take a while. I don't know why they put the full specification into a single HTML file. It's like it like breaks my beefy computer. The answer is yes. Okay. While the render pass is active. Okay. But not inside a command buffer recording. Ah, okay. What? Wait, how can I while a render pass is active? Oh no. But not while command buffer is recording. Damn. Okay, let's see. Host side versus command buffer. So we're going to use host side function. It updates the scripter objects in CPU memory driver, manage structure, a render pass. Okay, blah blah blah. What you cannot do, you cannot call updates inside the command buffer recording stream. Command buffer recording only allows Vulkan commands. It's not one of those. Ah. Render. Okay, so let's not do it in render. We need to do it before. So doing it before means that update chunks, update. Update. I'm gonna need an update function here, which is going to take, and we don't have the frame, right? The update function needs things that are not ready yet. So let's go back and see. I'm gonna close some of these functions. Okay, so first thing is present. So this should happen before that. And present, what does present do? We start the command buffer. We do this, render callback. We acquire, and it's gonna prepare with the command frame context. Okay, so the present index. So the present index is already computed. We need an update callback. Okay. We need an update callback. Do we need an update call? I mean, this is like, why would you even reset and then begin? Yeah, because it's this guy's handling the in-flight commands, command buffers. So we have all we need already here. Present. So the only thing that we don't have is the present, the command buffer. Begin command buffer recording, and then after this point we cannot do anything else. So we can craft a frame Okay, so present, render callback, and update callback. You're gonna have two callbacks. Which will contain almost the same things. But let me check if update. Yeah, update doesn't need a command buffer. Hopefully, update doesn't need a command buffer. Yeah, because everything that needs a command buffer, it can be run in the present function, like in the render callback. Okay. We're getting there. We just introduce a new callback. And it's gonna be the same, pretty much. Reset the command buffer. And begin the next one here. Or maybe I can just move everything to the bottom. And it's a block. Except for the fact that we don't have the command buffer. Well, I mean, it's the old command buffer. Is it safe to assume that I can use it? And reset command buffer. This is const, so it must be non-const at this point. And then we send it to the update. And then we set the command. So there's gonna be a null handle at first. And then you set it here. Okay. Makes sense. It makes sense. Now, let's replicate the render callback. I'm gonna call it update. And this is where, oh, well, I mean, the copy can be done after the fact, so we don't really need the copy to happen now. Copy can happen later. And copy commands, okay. The descriptor set can be set now. So the reset descriptor should not happen here. That is an error. And this stuff happens here. Whoa. Okay, because it's a big block of code. What is happening here? Okay, lots of things happening. In the frame, present. Let's give it the update first. The update. Can I bind it? So the update is as a function. Should I use std bind? Std bind. How does this work? Yeah, I don't know. Maybe not. Std bind. Let's do yeah, let's do a small lambda that then calls the update function. It's a bit messy. Okay. Update frame. What's wrong with frame? Huh? Create member update. Didn't I just do it? Update. Yeah. Oh, DT. Okay, no command buffer. Do we need delta time? Well, I can keep it, but not really. You don't need delta time. Okay. That's what I was missing. Where was I? Okay, here. And the same happens on the XR side. Yeah, let me just do both at the same time. I could do it later, don't need to do it right now. What's wrong? Okay, it's got a namespace, update callback. Then this might be a bit more challenging. Where does the command begin? The command begins here and shouldn't. Sync pose, command buffer. So command buffer is not really used anywhere here. First, no, this guy here. First place is used is in the same place. So the end command buffer render. So this guy only renders if it should render, but should it also update? Yeah, also update. So we want to call, but the command buffer is also created The command buffer doesn't need to be created, does it? It's because it's submitting. It is submitting it anyway. And command buffer. It creates it anyway. Well, I guess I can if the update as well. Because the command buffer needs to be created anyway, as otherwise everything would fall apart. Queue submit doesn't do work, but still does it. Because the compositor wants to be, I don't know. Does this need to keep happening? Yeah, this is a bit of a gray area. I don't know if you need to keep submitting frames even if should render is not active. Well, anyway, not a thing for now. I'm just gonna focus on the beginning of the frame, the command buffer. So I'm gonna place it here. Then I'll do the same for the update. Update should render what is happening. Okay, so the whole frame computation can happen regardless of whether it should render or not. Whoopsie. Please fix the indentation. Okay, so we got the frame. Then it changes, gets modified. Here I'm gonna set it to null. BK null handle should render. We do the frame.command, set it here after it's been reset. Yeah, I'm just setting it to null, just in case I'm gonna try to use it in the update function, so at least I get an error rather than an undefined behavior. Okay, let's normalize this side as well. Is gonna call update. Hey, what's wrong? Oh yeah. Can I pass null? Okay, there you go. Yeah, that's ugly. Actually, let's do auto empty Now I'm gonna call it nope. And nope. Okay, that's nope. No operation. Reminds me of the good old days of writing assembly by hand. Who knows what a nope sled is? It's a trick used for hackers that wants to get into a specific place. If you don't know where to land, where the jump of the code begins, then you just put a slide of nopes, and whenever the CPU instruction pointer lands, then it's gonna slide slowly. Not slowly, it's gonna slide and eventually get to the beginning of your malicious code. That's a nice trick and fun to use. So back to the update function, finally. Back to the update function. Now we have all we need to do. Write buffer. And we get the frame present index. Then we need the set index. The set is 0. Maybe I should create an enum. An enum. Just to give it a name. Set of 0 and 1. And the buffer that I need is the frame buffer. The buffer. The offset is gonna be 0, and again here we need to suballocate, so that is something to do. Okay, but the suballocation happens. Oh no, this is like pain. Okay, so this is so disconnected. The copy happens later. I could bulk the copies into another, like another command buffer. Not a command buffer, but I could make sub-command buffers and then run them afterwards. That's gonna make it super complicated. But I can make, just like the garbage collection, I can make a copy buffer and then run all the copies here. So that's okay. That should be a nice way to set this. So the problem is that when I do the write buffer, I don't have the suballocation. So I don't know it yet. I can do the suballocation and the update, and I have to do the copy afterwards. So how do I do this? I'm gonna start by moving. Buffer, I already know. So I already have full knowledge of this data. Except for the command that needs to run. So what do I need is frame the buffer and the suballocation. Well, easy. Easy. Let's just do it. We still need a buffer and the suballocation. So it's gonna be a copy buffer. this time it's just a vector. Vector of, again, oops, deleted it, of this stuff, and it's gonna be a copy buffers. Copy buffers, copy buffers. So instead of doing the actual copy, we do that, and here we do the copy buffers. So for the reference, here we do the structuring. We have the buffer, the sub buffer, and from the copy buffers array vector, and we do the buffer dot copy from SB, and what is this? The offset. We need the offset. Copy from, okay, we need the offset. Fair enough. Forgot the offset as a pair, then it's becomes a tuple. 1, 2, 3. PK device size, destination offset. Can I not name it? Device size, destination offset. Okay. And then destination offset. Hey, what's wrong? Copy from the command buffer. Sorry. Frame.command. Okay. You've got all that you needed. Now, from copy buffers, we just emplace the malloc and the buffer, which is frame buffer malloc 0. I can delete this. Cool. What else is missing? So we do the suballoc, and we do with the further copy. We defer the copy, but at the same time we have the suballocation. Now let's figure out the parameters. Frame.present index should be fine. Then the set is 0. The buffer is the buffer. The offset is gonna be the offset is gonna be 0 this time. And the range to copy, what is the range? The range is gonna be the suballoc size. Solid flat, right buffer. Suballoc size. Yeah, because the suballoc size is the size of per constant. Yeah, this is it. The size of. I hope it's the size of. Okay. It is. It's almost done. It's very close. we're just missing the binding. So what do we bind? What do we bind? I don't think I have a place for the binding yet. Okay, I'm gonna make a little pause to do things. I'm gonna be back in a few minutes. See you in a bit. let's get this done. So the descriptor set. Oh, let's think about it. So the descriptor set. So we need to bind a descriptor set. We don't have a way to retrieve it. So when we do an update, so we have the write, and the write, it's gonna write it, and it's also going to allocate a descriptor set. So we do have the write. So write might return the descriptor set that we then bind here. Okay. Guess we just have to take that into account. So write is not really write, it's an allocate. Yeah, allocate and write. And we get what? Well, we can get the descriptor set itself. So instead of returning true, yeah, we return an optional. So let's get the optional here and say that this is gonna be a stud optional. Stud what? You don't have it? Alt enter. Boom. Now you have it. Not yet. Use type stud optional. Yes. Did you do it? Good. So now that's gonna be a VK descriptor set. And yeah, this way. So we return a descriptor set. This line is a bit too long. Maybe my font is it's just too big. Yeah, that wasn't too long. It's just I can do it like this. Okay. So that is const. I can also const this guy and const this one. So he will return a null option and he will return the set. And this will be no discard. Then in the update here, when we do the write, we will also save the descriptor sets. That is, how do I save this information? Yeah, I need to group them. So this descriptor set is for the camera, is it? So this is well, the frame itself, like the act of rendering chunks, is a group of actions. So that is probably, and it has a camera from which to render. Yeah, that sounds like a good, fair way of grouping it. But for now, I'm just gonna throw a VK descriptor set in here. VK descriptor set. And this will be the frame descriptor set, which is going to be a null handle, and then the object descriptor set, and that's it. Yeah. I think I need to bind anything else. So why did I bind? What did I bind? Oh, there, the sets. The sets. I think this used to return both of the sets. Okay, so I need to remake an array here. This is binding the vertex buffer. That's fine. I think it's still valid. And why does it have the offsets? Yeah, there's no offset. It can be const expr. So I'll make the linter happy. Oh boy. This is an array of vk descriptor set. Actually, this can easily be inferred, and it's an array made of the frame descriptor set and the object descriptor set. And that's it. That is it. Don't need this guy anymore. We've got the two descriptor sets. I just did not set the second one yet, nor the first one actually. So that's going to be the frame descriptor set. It's an optional, so it's either value or vk null handle. Hopefully it's not null handle. So that's the suballocation. Update. So the reset. Where does the reset happen? Update. And then I need to do the update here. So that's a solid flat. Not reset. Why do you think I want to reset it again? I need to do an update. And here all the writes happen. It's just the update that is not sounding good to me. Yeah. Can it be made const? Okay. Yeah, I think it's plausible. Is it plausible? Like this can't be made const because it's a destination of a copy. No, this is not the destination of a copy. If I made it const, then its value is its value const? Yeah, I feel like this can't be const. Anyway, I need to bind the whole range. Yes, I need to bind the whole range. For the UBO, so what I can do is I can reset this guy and update it manually. Where do I do that? I could do it in here. So after the time is gone, I do the garbage collection and the chunk generation. I think the garbage collection should happen first. Then we generate. I'm not sure about, yeah, I guess this should happen in reverse. I think I put it that way just because I've made them in that order. So it's not like it was meant to be used in that order. Okay, getting super close here. And oh no, we don't have it yet. Guess what? I'm gonna leave the garbage collection there and move the generation. I'm actually moving the generation. Yeah, garbage collection belongs there, but the generation, I'm gonna move it to the update function, which we didn't have before, so I had to put it there. Wait, what? Oh, reset. Okay, so I forgot about this. So we do the generation, no, we do the reset, we did the generation, and then we do the update. Now it makes sense. Now I can do this. Because I have the VBO, right, which we don't need to write into the descriptors. We're going to use it directly. Then we have the UBO and the draw args. The drawing arguments. So the per object buffer. I feel like I'm forgetting the per object arguments. Object, am I using it? I don't remember if I'm using it. Per object, okay, I'm not using it directly. I'm just using the draw index object. Okay, I'm using the draw index. So I'm not using the indirect indexing. So all I'm left with then, I'm gonna use the indirect indexing later when I'm not doing the whole cleanup and reallocation every time, but I will deal with like single chunks at a time. That's a bit smarter than what I'm doing right now. So I'm gonna get the suballocation, and this is not the frame descriptor set. This is the object descriptor set. And I'm gonna write. The set is 1. That's the buffer. I think I forgot the binding. I forgot to put the binding here. Oh yeah, binding is 0. Yeah. I think I'll figure it out later when I need it. So frame buffer. No, actually, that's a problem. I'm gonna put the binding here in 32. That's binding. We got the set index, binding index. It's probably belongs here. Yeah. Binding. Maybe const binding. And that is binding. Binding is 0. And here binding is also 0. So set 0, binding 0, set 1, binding 0. It's the object buffer. Copy destination. Okay, that should be it. Oh boy, this is gonna work. So much work. Let's see if it compiles. The moment of truth. This is the moment of truth. It's not even compiling. What happens? Render pass. Oh wait, wrong location. Yeah, you're right. What is this? It's not const expert because why? Oh well, because it's relying on flags. Oh wait, I'm not using flags. I'm not using flags. Come on. Lucky I got this hint. Okay, now we're using flags. This isn't const expert. Depends on parameters, runtime parameters, which might not be const expert. They could be const expert. They might not be, because the function itself is not const expert. And we got the flags. Failure caused by a read of a variable outside its lifetime. Whoa. What? Maybe it's related to the const expert anyway. So this is const outside of its lifetime. Because of the const. Yeah, probably just depends on the const expert. Okay, more in the cube. I'm not using cube anymore. Just need to vertex buffer. I'll comment this out. And such. Yeah, I'll have to update this code eventually. More code that needs to be updated. Maybe I should update this. And size. So what is missing is the usage. So VMA host prefer host. So this is the thing that's missing. That's reasonably easy to fix. Okay, is everything cool now? Term does not evaluate to a function taking 0. What? This is not the function. Ooh, okay. Where is this happening? Okay. I probably misused copy. There is probably some copy. Can you just tell me where it is? Okay, here. Copy. Okay, so even copy doesn't like void star pointers. So I'll have to reinterpret cast, not to statically cast. To what? Per frame const. So this is a per frame const. And it's a pointer. And it's just one object. Per frame const into there. Ooh, it compiled. I want to run this, but first I need to make sure that the simulator is not on. So give me a policy. Okay, now let's run the deactivate just in case. Okay, this should run in a windowed mode. Also want to go to the Vulkan SDK and the Vulkan config to raise breakpoints when something bad happens. Break, okay. This is active now. And let's debug it. Pretty sure there's no way this is gonna work at first run. Okay. That was quite obvious. Let's see now what is going on. Create pools. Okay, what's wrong? Create pools. You got the device. Did I not allocate the array? Of course I did not. That makes sense. Okay. That is fair. So I'm just gonna resize this guy. All right, fix number one. Dot resize, and we got it. Rerun. Okay. Number two. What's wrong? Oh, we don't have the device. Ew. Wait, why? What is this? Where is this coming from? So we are in the loop. And if we are in the loop, why don't you have failed to initialize OpenXR using Vulkan? Okay. Use it. Well, I mean, it loaded the shader, so there must be a device. But we are in the XR context. Why are you in the... Oh, wait. I did something dumb here. Yes, I knew it. So this needs to happen on the VK. Okay. That was another easy point. Okay. What is happening now? Encountered address access violation writing. Okay. There is a violation because this is null. Of course this is null. Staging buffer. Let's analyze the staging buffer. Allocation info. It is not mapped. How did I create the staging buffer? Let's go back in time to the beginning of everything. I did not create the staging. Oh no, I did create the staging buffer. Source. Well, actually, I didn't say that I wanted to be mapped. So I created the parameter, but then I didn't use it. How do I do that? I need somewhere to pick it from. Where's my fellow friend Vulkan? So when I do this suballocation, where did I use this? In the creation of the staging buffer. So create staging. Okay, I need these. I need these flags. We have a memory CPU, and then we have the flags. Okay. Boom. Got the flags. Now it should have all it's needed. You can keep moving on one step at a time. Another step, it's done. Now what do we have? What have we done wrong? You're trying to do the copy. Okay, I guess you're trying to do the copy and the command is null. Is it? No, the command is not null. The command is not null, so what is wrong here? Where are we first? Let's go back to debug. So we are lambda. What kind of lambda is that? Okay, we are in the render. That's good. Then inside the render we do the update chunks. So we did the update successfully. Now we do the update chunks. And what are we doing wrong? The command buffer. Source buffer is null. Source buffer is null. Which is this guy here. Okay, source buffer. Okay, so this is where we are breaking the source buffer. I should not be staging buffer. No. No, 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 no. What is a source buffer? Is source. We don't have the buffer. Okay. We don't have the buffer to copy it from. Ah. Okay, yep, that makes total sense. That makes a lot of sense. So at this point I'm thinking, why don't I, like, buffer suballocation should have, it should have a reference to the buffer. Got the pointer. We got the VK buffer reference, the buffer, and it doesn't know what a buffer is, so it's just a class. VK buffer, just buffer. Okay, yeah, you're already in the VK. So just buffer. That you don't know what a buffer is. Okay. Forward declared buffer allocations has a buffer. Now we can say source dot buffer. Why not? VK buffer, source buffer. What's wrong? Due to compiler okay, no, we just have to stop. What is the error? VK buffer. Okay, so it's oh, the VK buffer it belongs to. Well, I want the buffer container. There's gonna be buffer as long as buffer exists. A pointer. Oh no. The stream is coming to an end. I'm gonna give you a warning. Beep, bop, beep. So we are not likely to finish this today either, but we are getting close. Almost there. Just need to refine a couple of things. And I would also say that since we have since the buffer allocation already get buffer, I guess I can just remove this guy. Or maybe not. No. I think it would be wrong to assume that we want... Yeah, this is too intricate. I think it's easier if we just copy from the buffer, VK buffer, or just might be a buffer like this, or it could be just a row buffer. Who cares what type of buffer it is? VK buffer, source buffer. This is totally fine. Without having to change all the code. Copy from is now it's changed. Why is it not updating? Oh, okay, it is updating now. So the copy from the staging. So this is going to be staging buffer. Buffer. And this also gets it from the staging buffer, and this is also from the staging buffer. You also get it from the staging buffer. Everyone get a piece of staging buffer. Yeah, that was quicker than changing the whole machinery. And it's much more obvious. You don't need cross references. Okay. Getting another. So destination is no. Ooh. How did this happen? We require the size of 1254 times, and this returned no. Suballocation failed on the staging buffer. Huh. How many allocation do we have already? Draw args. This delete buffers. It's only 3 buffers to delete. But staging buff. What is this? Oh, there's a big. Oh, there's a lot of data in here. Huh? Now that can't be. That looks like half a gig. And chunks vertex buffer. The vertex buffer. Ah, but that's just this buffer. Yeah. No, I need the allocation. First, second. What is first? Okay, the second, and then chunks vertex buffer, and then the suballocation. Okay, the size of the suballocation is okay. This is just 22 megs. This is just 22 megs. And here, second is staging buffer. Okay, we need to deallocate the staging buffer. And there is a suballocation of, yeah, the 22 megs. That's fine. So that's the same. Chunks per frame. And we didn't deallocate that. The per frame suballocation. Delete buffer. The suballocation from the staging. Yeah, it's from the staging buffer, not the per frame. Let's be clear about that. Okay. The other ones are good. And I'm still not sure why this is not getting it right. I'm gonna try again. Let's see. Maybe I'll just make it bigger. Let's see if that changes something. So when I create the staging buffer, let's make it 512. That is big. Let's see if half gig of memory is enough. Okay. Update chunks. Oh, we're still here. Suballocation failed. This is interesting. And so we need to break it down in here. See what is going on under the hood. But I'm afraid time is over. We're getting into the fun bit. But we will have to resume it next time. I just want to do a little check of what's happening. Virtual block, okay, we do have created. Now, why is it failing? Okay, we do have out of device memory. Is it because it's trying to allocate it? It's trying to allocate it from the staging buffer. Is it? No, it can't be. Why is it out of allocation info? So we have the virtual block info, virtual block. We have the virtual block, Metadata, blocks free. What is the size? Well, whatever. I'm gonna stop it here before starting to dive into this rabbit hole. I guess there is a problem in the allocation, but I'll figure it out. Cool. That's it for today, folks. See you next time. Have a nice day. Bye bye.